All right, so I had some questions on the cross product this week, which makes complete sense. It's kind of the weirdest part of this vector chapter. Well, I guess not necessarily weirdest, but definitely the most involved. There's a lot of steps, and um, it can be kind of unclear why you would want to do this or what some of this notation means. So let me just start by saying it's how you can find a vector that's orthogonal or perpendicular to two other vectors in 3D space, used for 3D modeling, physics, and whatever else people do with their lives. So we're going to find the cross product of u and v. This is problem number 11. This is actually part of your assignment. So here's one of the problems done for you. So the first thing we want to do is make a matrix, basically. And we've talked briefly about matrices in the past when we did systems of equations. We didn't really dive too deep into them, but there's a lot of different operations you can do with those. So we're going to make a matrix. It's going to be 3 by 3 with our letters I, J, and K at the top, our three unit vectors in the X, Y, and Z direction. And then we have u is going to go right underneath there, all the coefficients of u. So 6, 2, and 1. And then underneath that, the coefficients for v. So 1, 3, and -2. All right, so the matrix notation here is a little bit different because technically we're finding the determinant of this, and that's why you get these straight bars on the side. Usually with a matrix you have more of these brackets on the side, so slight difference in notation, not really something that we're worried about right now. So let's move on to the next step. So once you do this, our equation is, or formula I should say, it's on the formula sheet. It's the last one there, cross product. And this is written a little bit different. This is saying that if you had, vector u being made up of u1 plus u2 plus u3 as your coefficients on I, J, and K, then you can set it up that way, and v would look the same way with v1, v2, and v3, and then you can just plug those in. So if you want to use that method, you can. So let's go back to this one. We want to create find the coefficient on our new vector for I, and that's going to be by taking everything that's not in the I row, so basically this stuff here, and putting those together. Now the book shows it as 2, 1, 3, and -2, and then you have I next to that. And then we're going to subtract, and we're going to do the same thing with J. So now if I got rid of this, for J it's going to be the numbers underneath K and the numbers underneath I, and those are going to make their new matrix or new determinant. So 6, 1 underneath that, 1 and -2 over there, J next to that. And then finally we have K, and for K we don't want to use the numbers in the K column, we want to use the others. So 6, 1, 2, and 3 is going to make up our matrix in front of K. All right, notice we're adding K at the end, but we are subtracting J here. So it's I minus J plus K. Again, use your formula sheet. So the next step, the video that's posted for this lesson does not really explain this next step very much because it's based on the determinant from our matrix chapter, which we did not cover. So what they're doing is they are cross multiplying inside those matrices. So this 2 and -2 are going to be multiplied. This 3 and 1 are going to be multiplied. Hence the cross product. That's where that name comes from, because you're crossing these in the determinant multiplication. And if you're hearing me say the word determinant over and over again, and not knowing what it is, that's fine. Again, it comes from the matrix chapter that we didn't cover. It's just some vocab from that chapter. So we multiply these numbers here, 2 and -2, and then we subtract the multiplication of 3 and 1. And now all of that is the coefficient on I. Now same thing for J. We're going to multiply 6 and -2. We're going to multiply 1 and 1. 6 and -2 minus 1 times 1. J. And then same thing for k, multiply 6 and 3. This time we're adding. So add 6 times 3 minus 2 times 1 goes in front of k. And then we will simplify. 2 times negative 2, negative 4, minus 3i. We got negative 12 minus 1, j. 18 minus 2, k. And then final step of simplifying, negative 7i. Be careful with your negatives here. This is negative 13. With the negative out front makes that positive 13j. And then 18 minus 2 is going to give us 16k. That is the answer to our cross product. That is a vector that's perpendicular to the two original vectors, or orthogonal. So there's a cross product. Hope that helps.